Hi students, now let us continue the adapted design pattern implementation section. Now we discuss implementation section, listen carefully. In implementation section, although the adapter is usually straightforward, ma'am, so here we need to study some issues to keep in mind. Okay, the first one is nothing but implementing class adapters, implementing a class adapters in C++. Coming to the C++ implementation of a class adapter, adapter would inherit publicly from a target and privately from adaptee. So the adapter would be a subtype of a target. So the adapter would be a subtype of target but not of adaptee. Okay, and coming to the second key issue of adapter, pluggable adapters. Let's look at three ways we need to implement a pluggable adapters for the tree display widget describes earlier only, which can lay out, and we need to display a hierarchical structure automatically. Here we need to study the narrow space, the narrow interface, how to lead the three implementation approaches by using this adapter design pattern. We implemented with abstract operations. Using abstract operation, we define a corresponding abstract operations for the narrow adaptee interface. In the narrow adaptive interface in the tree display class. So we need to study here some subclasses must implement the abstract operations, and we need to adapt the hierarchical structured object. For example, here tree displays there subclass, the directory tree display subclass will implement these operations by accessing the directory structure. So the directory tree display, what it need to specialize is there the narrow interface, so that it can display the directory structure. In the sense, the directory structure, it displays the directory structure. It will made up of file system entity objects like directory a browser. Okay ma, where it will made up of a file system entity object, in the sense the directory a browser. Okay, this is nothing but implemented with abstract operations. Now we need to study using delegate objects, how we need to implement it with using with delegate objects. How? In the sense, in this approach we need to study a tree display forwards request for whatever we need to accessing the hierarchical structure to a delegate object. So the tree display can use a different adaptation strategy by substituting a different delegate objects. For example, I need to say, suppose there exists a directory browser. Yes, we need to exist a directory browser. It might make a good delegate it might make a good delegate for adapting a tree display to the hierarchical directory structure. So in dynamically we need to type language like a small talk language or object to C language. This approaches only, it requires an interface, okay, for registering the delegate objects with the adapter design pattern. So then the tree display simply forwards the request to the delegates. The next step, whatever you need to use this approach, it is very heavily we need to reduce the subclassing there. We need to decrease the subclassing. Statically we need to take some typed languages like C++. It requires an explicit interface definition for the delegate object. We need to specify such an interface by putting the narrow interface that tree display requires into an abstract tree accessor delegate a class. Look at this right side here. We can specify the tree display requires into an abstract tree accessor delegate class. Then we can mix this interface into the delegate of our choice. So the directory browser, in this case we are using inheritance. We use a single inheritance if the directory browser has no existing parent class, and multiple inheritance if it does need. So mixing classes together like this, it is very easier than introducing a new tree display a subclass, and we are implementing its operations individually. We are implementing this operations. This is nothing but implemented with delegate objects. And coming to the two-way adapters in the sense, let us take this is nothing but parameterized adapters. How the usual way we need to support the pluggable adapters in small talk is to parameterize an adapter with one or more blocks. So the block construct, it supports adaptation without a subclassing. So a block can adapt a request, and the adapter can store a block for each individual request. Okay, this is the two-way adapter. So how the sample code will be written. And coming to them to adapting local classes to remote interface, let us take the comparison here. If the remote client will send some remote interface and remote methods, the java.rmi.remote it will inherit some remote interfaces and methods, and the remote adapter request the specific domain adaptee like local class, local method. Okay, local class, and coming to the local method, let us see the adapting local classes to remote interface. The comparison is we need to increase reusability of local classes. We need to enhance reusability of whatever which designers use to solve that common problem. We need to enhance reusability of local class, and we need to improve performance of local classes. And we doesn't use Java single parent class. By subclassing we need to use a composition. Okay, now what are the related design patterns of adaptive design pattern? Adapter can be very similar to the remote form of a proxy. However, proxy does not change its interfaces. And coming to the decorator enhances, in the sense increases another object without changing its interfaces. We need to increase another object. Decorator, in the sense, if you need to adding some additional functionality dynamically, we are adding some embellishments, decorations. Okay, and coming to the bridge section, we need to decouple the abstraction from its implementation. It is very similar structure. The bridge is very similar structure to adapter design pattern, but the different intent. So it separates the interface from its implementation. And coming to the finally, I conclude this adapter design pattern. Adapter design pattern, it allows a collaboration between classes with incompatible interfaces. Yes, adapter pattern works as a bridge between two incompatible interfaces. Like, what is the collaboration here? A client, clients call operations. Clients call an operation on an adapter instance. So in turn, the adapter calls adaptee operation. Adapter calls adaptee operation that carry out their request, that carry out their particular responsibilities. Once again, I have to repeat, collaboration concept related to abstract design pattern. Clients call operations on an adapter instance. In turn, whatever the adapter design pattern calls adaptive operations so that carry out the particular request or to carry out their responsibilities. So we need to implement it in either how the class based we need to implement it in either class based or object based. Class based we need to take inheritance, or object based we need to take a composition or and delegation. Composition and delegation objects a manner. Okay, we need to implement it in either class based inheritance or object based composition and delegation a manner. It is very useful pattern which promotes a reusability, and it allows integration of a diverse software components. Okay, it is very useful pattern which we need to promote reuse, and it allows integration of a diverse software components. Okay, and what the adapter if you need to have the legacy code and current client, in the sense whatever the client expected, we need to convert the interface of a class to another interface whatever the client expected. The adaptive design pattern allows to incompatible classes to interact with each other if you need to have some legacy code and whatever the current client. Here the adapter design pattern changes interfaces of legacy code so client can use it. Okay, the client can use it. When the client can use it, adapter changes the interface of a legacy code. And coming to the next point, adapter fills the gap between two interfaces. The adaptive design pattern allows two incompatible classes to interact with each other. We need to fill the gap between two interfaces. Here no need to change for either legacy code or client. This is nothing but adapter continuation, some sample code, something given like a class name, taking some specific class specifier, access specifier public. We have to take some int type, get time some function. If you need to return some hold time, and you need to get the time asterisk 1000 plus 8 semicolon. Now thing coming to the private section, hold time m underscore hold time. Let us, if we have to declare some, if we have to create some classes to interact with each other from interface of one class to another class, whatever the client expectations. If you need to take some get time and return that hold time, and now getting some hold time and get new time also. Okay, this is the sample code of adaptive design pattern. Okay ma, thank you. If you have any doubts regarding the adapter pattern, can you please contact me. Thank you.